Hello, in this video we are continuing our discussion of Unit 13 on second order linear differential equations. In the previous video we had just finished up part D, which asked us to explain why a guess of a times t times the cosine of 5t was insufficient to find the particular solution for this differential equation. We also worked through why a guess of a cosine 5t plus b sine of 5t would not work either. So the conclusion that we came to in part D is that we needed, to choose something that involved both cosine of 5t and sine of 5t. So we're going to try a guess of t times a cosine 5t plus b sine of 5t. And we're going to use this to find the particular solution to the above equation. Now I want to warn you, if you are working through this on your handout, you might need more space than what is given. I have actually given myself quite a bit more space because I am writing fairly large in this video. So if you do write large yourself, you might want to write these notes on your own paper, or at least continue on your own paper if you run out of time. So how do we use a guess to find a particular solution? Well, we differentiate it, we plug it into our differential equation, and we see what we need to make a and b in order to make it work. So we need to start with a derivative. So I'm going to find an x prime of t. I don't actually need a first derivative to plug into the differential equation, since the differential equation only involves the second derivative, but of course I need the first derivative in order to get to the second derivative. So this is where we're starting. So the first derivative is going to be t times the derivative of, excuse me, a cosine 5t plus b sine of 5t. So that will be negative 5a sine of 5t plus 5b cosine of 5t plus the second, which is the cosine and sine part, times the derivative of the first, and the derivative of t is just 1. So we're going to add a cosine of 5t plus b sine of 5t. And now I'm going to find the second derivative. We'll have to use the product rule again. First times the derivative of the stuff involving the sine and cosine. So that is going to be negative 25a cosine of 5t minus 25b sine of 5t plus the second times the derivative of the first. That's a 1 again, so we'll rewrite this negative 5a. Let me change that. Negative 5a sine of 5t plus 5b cosine of 5t. We are not done with our derivative yet because we still have to differentiate these last two terms, but they are a little bit simpler. No product rule required there. That will be a minus 5a sine of 5t plus 5b cosine of 5t. And just to make it a little bit easier to substitute in, notice we do have like terms there. So I'm going to add my like terms. I'm also going to distribute this t. So we'll have a negative 25t, or 25a t cosine of 5t minus 25b t sine of 5t minus 10a sine of 5t plus 10b cosine of 5t. That's our second derivative. If you recall, our differential equation is d squared x over dt squared plus 25x. The left side of it is anyways. The right side of it involves a cosine of 5t. So we'll take what we have for our derivative and our original function, and we'll substitute it in here for our second derivative, So that's a negative 25a cosine of 5t minus 25b sine of 5t minus 10a sine of 5t plus 10b cosine of 5t. That's all just our second derivative. Then we have plus 25 times x, and x is t times a cosine of 5t plus b times the sine of 5t, and a few parentheses there. If we distribute, I'm not going to write all of this out, I'll just write it as a side note. Notice if we distribute this, we will get 25at cosine of 5t plus 25b sine of 5t, and those two terms cancel out with these first terms. So what we are left with then is negative 10a sine of 5t plus 10b cosine of 5t, and this is where we set it equal to something that we want to be true. We want it to equal the right-hand side. If we scroll back up here, the right-hand side is 10 cosine of 5t. So we want this to equal 10 times the cosine of 5t. Okay, so the right-hand side involves only cosine, the left-hand side involves sine and cosine. But remember, we can write this as a plus 0 sine of 5t, so we can equate our coefficients then. So this will imply that our coefficient of sine on the left must equal our coefficient of sine on the right. So negative 10a must equal 0. And a 10b must equal 10, which means that a must be 0 and b must be 1. So our particular solution, y sub p of t, will equal t times a, which is 0. So we're actually, well, I'll go ahead and write it in there just so we see where it's coming from. Oops. Yes. Times the cosine of 5t plus b, which is 1, times the sine of 5t, and that whole first term just goes away. So we are left with t sine of 5t as our particular solution. And that wraps up number 16. But we're going to continue on in this video with number 17 because it uses what we did in part 16e. This says use the results from problems 10 and 16e to find the general solution to this differential equation. Now, if you recall, the general solution to a non-homogeneous equation is found by adding the homogeneous and the particular. Well, the homogeneous we found a ways back in problem 10, although I did rewrite it in the previous video, and then the particular solution we just found in the previous problem. So the homogeneous solution was c1 cosine of 5t plus c2 sine of 5t, and the particular solution was t times the sine of 5t, and now we're done. So it might have taken us a while to find our particular solution, but once we had it, all we had to do was add to our homogeneous solution in order to get our general. Now, we are going to continue on with this problem to find a specific solution when we have some given initial conditions. And this is something we have not done yet with second order equations, but it is very similar to what we saw in first order. We just end up having two initial conditions to substitute in because of the fact that it's a second order differential equation, and that corresponds to the fact that we have two unknowns that we have to solve for. So two conditions, two unknowns, we will end up with two equations to use to solve for our two unknowns. So let's go ahead and do that here. And in all honesty, I may need a little bit more room than this to work it out. I'm not sure how large I will be writing. So let's do, first off, x of 0 equals 0. Oops, I definitely used the wrong letters up here. I'm sorry. Let me erase those and make those x's, since that is the dependent variable in our problem. Okay, and I'll write this as x of t. Okay. I did that up here too. I'm sorry. Okay, so we have x of 0 equals 0, which means we're going to take 0, plug it in here for t, set it equals 0, and see what we get. So x of 0 is c1 cosine of 0 plus c2 sine of 0 plus 0 times the sine of 0. So these last two terms equal 0. Cosine of 0 is 1. And x of 0 should equal 0. So this whole thing should equal 0, which ends up giving us just that c1 is 0. That's a whole lot of zeros there. Next, we have the condition x prime of 0 equals 1. In order to get, or in order to substitute 0 into x prime, we need to know what x prime is. So I'm going to go ahead and write x prime up here to use my space a little bit better. The derivative of c1 cosine 5t is going to be negative 5 c1 sine of 5t plus 5 c2 cosine of 5t, and for this last term we need the product rule. T times the derivative of sine of 5t will give us a 5t cosine of 5t plus the sine of 5t times the derivative of t, that's just a 1, so it's just going to be the sine of 5t. Now we take that and we substitute 0 into it, and we set it equal to 1. So substituting in 0 for x prime, negative 5 c1, oh, and you know what? We could actually simplify this here, but by substituting in our known value for c. But you don't always know what c is at this point in general, so I'll just go ahead and work it out with keeping the c1 in there. Negative 5 c1 sine of 5t, or sorry, 5 times 0, that's just going to be a 0, the sine of 0, plus 5 c2 cosine of 0, plus 5 times 0 times the cosine of 0, plus the sine of 0, and again you have a bunch of things that go to 0. Cosine of 0 is 1 again, and this whole thing should equal 1. So this means that you end up with 5 times c2 equaling 1, or c2 is 1/5. So for the specific solution, we need to take these values for c, substitute them in here, sorry, not in there, into the solution to get the final answer. So x of t is equal to, c sub 1 was 0, so that whole term goes away. C sub 2 is 1/5, so we will have 1/5 sine of 5t plus t sine of 5t. 1/5 sine of 5t plus t sine of 5t. And there is the complete solution that satisfies the differential equation d squared x over dt squared plus 25x equals 10 cosine of 5t with the initial conditions x of 0 equaling 0 and x prime of 0 equaling 1. And that is where we will stop with this video. I will finish out the last of this unit in the next video.